camber. The front of the vehicle is that way. If the true vertical center line of the tire and wheel looks like this, then moving the tire and wheel outward creates positive camber. Positive camber wears the outer edge of the tire. Moving the tire and wheel inward creates negative camber. Negative camber will wear the inner edge of the tire. Incorrect camber can cause a pull. If the cross camber is more than half of a degree, then the vehicle could pull towards the side with the most positive camber. That's the side with the most positive camber. Caster. This is what 0 degrees caster looks like. The front of the vehicle is that way. If we move the upper strut mount and lower ball joint line towards the driver, this creates positive caster. Moving it towards the front of the vehicle creates negative caster. The majority of vehicles are set at a positive caster setting. Here, directional stability is maintained and the steering wheel returns to center after a turn. Excessive positive caster increases steering effort, leads to a harsh ride, and the steering wheel rapidly returns to center after a turn. Negative caster, you'll get poor steering wheel returnability and reduced directional stability. Caster is not a direct wear angle. Incorrect caster can cause a pull. If the cross caster is greater than a half of a degree, the vehicle could pull towards the side with the least positive caster. I'm remembering this number as a general number. Some specifications state that a cross caster difference as high as 1 degree can cause a pull. For the test, half of a degree is the magic number for me. Toe. The front of the vehicle is that way. Theoretically, we're at 0 degree toe. This is just an example. If we move the tire and wheel inward, we get a toe-in condition, also known as positive toe. If we move the tire and wheel outward, we get negative toe, toe out. Incorrect front toe can create tire wear similar to camber. But for the test, know that incorrect front toe causes feathered tire wear. Feathered tire wear. Incorrect front toe. Incorrect front toe does not cause a pull. This is because the front tires attempt to equalize while driving. A bump can disrupt this equalization, which leads to bump steer. Up next, we have toe out on turns. The wheel closest to the turn turns at a sharper angle. Here, I'm turning towards the passenger side, and the passenger side wheel is the one closest to the turn. If the driver's side turning angle was reading at 20 degrees, then the passenger side would read at about 22 degrees. It is toed out on turns. Know which components affect this angle. Moving on to rear toe. Incorrect rear toe does cause a pull and causes diagonal tire wear. That's diagonal tire wear, as opposed to front toe, which does not cause a pull, only bump steer and feathered tire wear. Rear toe affects the thrust line, which is the center line of the direction in which the rear tires are pointing. The thrust line should be the same as the geometric center line of the vehicle. If the right rear tire is toed out, then the thrust line would move to the right. Any deviation from the geometric center line creates a thrust angle. Front wheel alignment is based on the thrust line, so correct rear toe is very important. The order of alignment is rear camber, rear toe, front camber, front caster, and end with front toe. Know which components can affect rear toe and the ways the thrust line can be moved. One is through axle side set. This is when the rear axle is moved sideways, usually through an impact. Another way the thrust line can be moved is through rear axle offset. This could be caused by worn rear components such as leaf springs, leaf spring eye bushings, control arm bushings, etc. These worn components cause the axle to become off-center, therefore changing the thrust line. Steering axis inclination, aka SAI, is viewed from the front. It is the strut line, and the true vertical center line of the tire and wheel. If we add or subtract the camber angle to the SAI angle, we get the included angle. For the test, know which components affect SAI. If one of the questions asks you if an idler arm can affect SAI, you'll know that is not true. Is SAI a good angle to determine if the strut is bent? It sure is. And that's it on alignment angles. There's more alignment angles, but this information is the one that you should really know. I'll end the video with the joke. Why did the bicycle fall over? Why did the bicycle fall over? Because it was too tired. See you in video number 2, where we will talk about tires.